This lesson is on transformations of quadratics. Transformations are all about how things move. Let's first look at the basic quadratic function of y equals x squared. It has been graphed for you. Notice that the vertex is on 0, 0, and it opens up. This is the parent function of quadratics. We are going to analyze transformations on this basic equation in vertex form. Remember that vertex form is y equals a x minus h squared plus k. And remember that h and k are your vertex. You do the opposite of what's in parentheses and you keep this one the same. All right, so if we were at school, we would do a partner experiment, but alas, we're not. So we are going to graph and state the transformation from y1 equals x squared. So this is x squared. And then we want to know what happens if you do parentheses x minus 5 squared plus 3. Feel free to pause your video and type that into Desmos so you can see what it looks like. When you put it into Desmos, or some of you know that the vertex, because this is already in vertex form, would be positive 5, positive 3. The axis of symmetry is always x equals, because it's a vertical line, and it's whatever your x coordinate is of your vertex. So the axis of symmetry is x equals 5. All right, here's what we want to learn new today. What transformations have taken place? So if you look at this in Desmos, it would be 1, 2, 3, 4. I'm sorry, 1, 2, 3, 4, 5, up 3. And so you can see that from the parent function, it has shifted right 5, or you could say translated right 5 and up 3. Translated right 5 and up 3. That's what transformations have taken place. All right, the next one, negative 2, parentheses x minus 4 squared. The vertex is 4, 0, because there's nothing back there. The axis of symmetry would be x equals 4. Once again, I encourage you to put that in Desmos so you can see what it looks like. It opens down and it is narrower than the original function. So let's talk about what transformations have taken place. Let's first do the easy one. Instead of being at 0, 0, it went right 4. Instead of opening up, it opened down. So what kind of transformation is that? It is a reflection over the x-axis. The negative in front is what makes it open down. The negative in front is what makes it open down. So that's what makes it reflect over the x-axis. And then this 2 in front is a dilation of 2. But whenever you're talking about quadratics, they use the word stretch or shrink. Stretch or shrink. So you can say it dilates by 2, and I would count that right. But if you are having a multiple choice problem and you don't see dilate by 2, it would be stretch by a factor of 2. They might use that language instead of dilate. Okay, so you are multiplying by 2, which is a dilation, and we call that a stretch. When you stretch it, it actually makes it skinnier. Think about a rubber band. As you stretch it, it actually gets skinnier. All right, and then our last example for now, 1/2 parentheses x plus 6 squared minus 3. Again, I encourage you to put that in Desmos. The vertex would be negative 6, negative 3. This one opens up because it's positive, and the 1/2 actually makes it wider when you multiply it by 1/2 because you're shrinking it. Think about when you crush a soda can with your foot. When you stomp it, the soda can actually gets wider. All right, your axis of symmetry, x equals -6. All right, transformations. We'll first talk about from 0, 0, it went left 6 and down 3. Remember, you can pause this video at any time if you need more time to write or you want to rewind it a little bit and listen again. All right, and it also dilated by 1/2, but again, you're not going to see dilate on a lot of the multiple choice questions. This one's going to say it shrinks, and it's actually called a vertical. This would be a vertical stretch as well. A vertical shrink factor of 1/2. Sometimes they also use vertical compression as a word, so you have to just get used to all the different words that they use. All right, so in summary, remember y equals a, x minus h squared plus k. The h moves it to the left or to the right. Whatever's in the parentheses is going to move it to the left or the right, and that makes sense. Look at the examples we just did. The 5 moved it to the right 5. The 4 moved it to the right 4. The 6 moved it to the left 6. Remember, you have to do the opposite of what's in parentheses. Your K moves it up or down. So what's on the outside moves it up or down. This one moved it up 3. This one, it didn't move up or down at all. And this one moved down 3. If your A value, remember A is this number in front. If A is positive, it opens up. If A is negative, it reflects over the x-axis. All right. If A is greater than 1, so up here, 2, and this should be the absolute value of A. So ignore the negative, just concentrate on the 2. It stretched it vertically. If it's less than 1, it compresses it vertically. Okay. All right, let's do some more examples. F of x equals x minus 3 squared plus 5. Remember that Desmos is your best friend, so you can always put these in Desmos. All right, your vertex would be 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. Does this one open up or open down? Well, it's positive, so it opens up. So that means that this point is a minimum because it opens up. That means that your vertex is a minimum. All right, what transformations happened on this one? The only thing is it moved right 3 and up 5. Those are the only 2 transformations. Okay. All right, what about this one? Your vertex is -3, -4. This one is also positive, so it would open up. So that once again would mean it's a minimum. And the only transformations on this one are left 3, down 4. All right, this one, your vertex is +1, +6. And so 1, 6. And got a +3 in front. So it still opens up and it's going to be skinny. So it's still a minimum because it opens up. And for transformations, it goes right 1 and up 6. But then you have to talk about what this 3 does. It's a dilation because you're multiplying. But instead of using the word dilation, we're going to say either a stretch or a shrink. If it's bigger than 1, it is a stretch. And it's always going to be a vertical. You don't do horizontal stretches until math 3. All right, so it's a vertical stretch. All right, and then we have number 4. The vertex would be -4, -2. This one has a negative, so it opens down. So that would make this point a maximum because it's at the top. All right, for the transformations, it goes left 4 and down 2 because your vertex, it moved left 4 down 2. You treat the negative and the 1/2 separately. Those are 2 separate transformations. You treat those separately. The negative makes it open down, which is a reflection over the x-axis. The 1/2 is the dilation, which when you're doing quadratics, you say stretch or shrink. So this is a shrink because it's less than 1. So it is a vertical shrink, or sometimes they use the word compression. Okay. All right, let's do one more thing. So once again, you have the parent function, f of x equals x squared. Find the following compositions and name the transformation that occurred. All right, so what do I mean by composition? We have to put x minus 3. It's in parentheses. We have to put it into the function, all right? And our function is x squared. So it's going to be x minus 3 and then squared. So in the x spot, you're putting in x minus 3. And you're going to leave the parentheses with it. So it's x minus 3 squared, right? Name the transformations. Well, if it's in the parentheses, it moves it left or right, and you do the opposite. So this one moves it right 3. Okay? All right, now this one's different. This one, the +2 is not in the parentheses. F of x is equal to x squared. So you just replace that with x squared, and you drop down the +2. So that's your answer for the composition part. Name the transformation. Well, if it's at the back, if you're adding or subtracting it and it's not in parentheses, it moves it up or down. So this one moves it up 2. All right, notice that this one is in parentheses, so you're putting it in the function. X plus 4 with a square on the outside. If it's in the parentheses, it moves it left or right. So this one moves it left 4 because you do the opposite. All right, notice that this one is not in the parentheses. So you just replace this with x squared, because that's what it says right here. F of x is equal to x squared. And then you drop down the -5. If you're adding or subtracting, it moves it up or down. So this one moves it down 5. All right, notice on this one, they have multiplied 2, and then we can replace that with x squared. This is a dilation or a stretch, a vertical stretch is the language that they're going to use, okay? All right, this one has 2 things going on. Negative f of x is x squared plus 1. All right, the negative makes it reflect over the x-axis, and the +1 moves it up 1. All right, this one you have 8 times, and then this is in parentheses, so you keep it in parentheses. If you're wondering where the square came from, it comes from the f of x, because f of x is x squared. All right, so the 8 is a vertical stretch by a factor of 8, and the +10 moves it left 10, because you have to do the opposite. This one would be 1/3 x minus 7 squared. And this is a shrink and